morning, children. My name is Ramakrishna, working as school assistant physics at Government High School Burgampahad. Now, welcome to the session. Here, I am going to discuss 7 to 12 chapters. The first chapter, that means the 7th chapter, that is classification of elements and periodic table. In this chapter, mainly, first, there is a need of classification of elements, and about the classification first attempted by the scientist Ramakrishna, you know it, and he is very famous with the Ramakrishna triads. And here there are some examples: lithium, sodium, potassium, sulfur, selenium, tellurium, chlorine, bromine, iodine. Like that, some examples may be asked in examinations, very important. And we know that the middle element's atomic weight is the arithmetic mean of first and last element's atomic weights. So this is about our traits. Next, later on, here we go to the Newland's concept of octaves. Newland's concept of octaves. And according to Newland's law, here every first and eighth element resemble in their characters. Okay. Next, we go to the Mendeleev's periodic law. Here, the Mendeleev's periodic law states that the physical and chemical properties of elements are the periodic functions of their atomic weight. Atomic weight here is very important. That means the periodic law totally based on the atomic weight. Next, he also constructed some periodic table also, and there are some differences also in the dominant triad, Newland's concepts, and Mendeleev periodic law also. And again, that was modified by the scientist H.J. Moseley. He is famous about his atomic number concept, and according to Moseley's concept, he also proposed one periodic law which states that the physical and chemical properties of elements are the periodic functions of the atomic number. That means he replaces the atomic weight concept with atomic number concept. And that law was based on that law only. He also constructed one table called modern periodic table, which we are using nowadays. That is nothing but modern periodic table, also called as long form of periodic table. Here, okay, this was Moseley's periodic table, also called as modern periodic table, which was based on the atomic number, and further that was also based on electronic configurations. So the law also defined as the physical and chemical properties of elements are the periodic functions of their electronic configurations also. This is also known as modern periodic law. Okay, we see the modern periodic table proposed by Moseley here. Look at the table. Here there are totally the horizontal, some of the horizontal rows and the vertical columns also there. These vertical columns are called as groups, and vertical columns are groups, and these horizontal rows are called periods. Here these are the periods, totally 7 periods and 18 groups are there. So that's why this is called as long form of the periodic table. Total groups are 18 and periods are 7. Right? Here the periodic table also divided into 4 blocks, namely S block, here the P block, and middle of S and P block, this is the D block, and the bottom of the periodic table consists of F block. Total there are 4 blocks. The S block consists of first 2 groups, first A and second A, and the 6th A to 8th group, these are also known as P block elements. In between the 10 groups, they are known as D block elements, and F block consists of 14 and 14 elements. Okay, here the first 2 groups also called as alkali metals, and the second group elements called as alkaline earth metals. And here the 8A group are also called as zero group elements or local gases or inert gas elements. Here the 7th group elements called as halogen family, and here the 6th group oxygen family also called as chalcogen family. Okay, next here the elements coming after lanthanum, that means from cerium to lutetium, the 14 elements are known as lanthanides, which comes after lanthanum, and also the elements 14 elements comes after actinium, which are coming from thorium to lanthanum are called as actinides. Here in examination, some of the questions based on these periodic properties, some periodic properties are there, which are from left to right in periods or in groups from top to bottom. They vary. Their periodic properties are mainly atomic radius, ionization, energy, electropositive character, electronegativity, and also electron affinity. These are the different periodic properties which may vary in periods and in groups. In examination, here different questions are asking based on this, how the following properties vary in a group and in a period, and I explain why these questions are coming in examinations. For example, here we have one short notation to write this answer. For suppose here you place this as groups, and also this is period, and first atomic radius, right, and ionization energy, also same as the electron affinity, and next here electropositive character, next electronegative character, you write like this. And here in groups, generally the atomic radius increases from top to bottom. Here we show like this. And in periods, the same atomic radius from left to right decreases. And next here ionization energy is opposite atomic radius in groups, that is from top to bottom, that decreases, and again in periods the same ionization energy increases from left to right. Next here electropositive character is same as the atomic radius. Here that also in groups from top to bottom increases, and also in periods from left to right that decreases. And electronegativity character is opposite electropositive character, so that is decreases from top to bottom in groups and increases in periods from left to right. So by using this concept, you can answer different questions asked in examinations. Like that, for example, here in examination some elements are given like that: potassium, calcium, like out of these two, which has more size or which has more ionization energy, like based on this using this concept you can write the answer. Okay children, now we are going to some other topic that is very important in our lesson, that is nothing but factors affecting the ionization energy. So you know that ionization energy is also energy which is required to remove electron from the outermost shell of an atom. So here these are some of the factors mainly, that is one of the important question. One is nuclear charge, next one is stable configuration, next one penetrating power of orbitals, next one atomic radius, and also screening effect, also called as shielding effect. So out of these all, we should write only any four for the 4 marks question. Here these three are increases when ionization energy also increases. Here atomic radius increases, ionization energy values decreases. Here the screening effect also increases, ionization energy value also decreases. Here these two are affecting one thing, one line right to one thing, and also these two factors are different. different. So based on this, you can write the answer also simply. Right. Now we are going to discuss another model question, very commonly asked in examination, that here for suppose A, B, C, D are different elements, and their electronic configurations are like this: 2, 8 and 2, 3 and 2, 3, 2, 8, 1 and 2, 8, 7. So frequently we see these type of questions, and out of these, based on this table, is giving some questions. For suppose which two elements belongs to same period, or which two elements belongs to same group, or whose valency is same, and how many valence electrons are present in element C or element B, like the different questions. For example, how to answer this type of questions we see here. Here first you have to identify the group number and period number first, and to identify the period number, here you see the number of how many numbers are there in each electronic configuration. So the valency shell here gives you what? Period number. That is nothing but period number. And valency electrons gives you what? That is group number. Here simply you noted it as valency shell periods. Suppose these are part-1 VSP. Valency shell number is the period number, and res nothing but valence electrons are the group number. Like that you keep in mind, and you may answer the question. Here, what is the valence shell? Here, second shell is the valence shell. Here, the period number is 2. Here also, the second shell is the valence shell. Period number is 2, and that belongs to second period. Here, the valence shell is 3, so the period number is 3. Here also, that belongs to third period. The element G also belongs to third period. Okay, and how to identify the group number? Group number is nothing but the valency electron number. Here the valency electron is 8, so that's why the element belongs to 8th A group. And here the valence electrons are 3, that belongs to 3rd A group. And this is the 1 valence electron, so this belongs to 1st A group. And these are the 7 valence electrons, so that belongs to 7th A group. In this way, we conclude that we identify different period number and group number. And also the valence electron numbers. Here we write based on this last number is the valence electron number. And here sometimes valency also is asking, valency is different from the valence electron concept. Here how to identify the valency of an element? Nothing but here the group number is the valency up to 4th group. That means for first group, second A group, third A group, and also for 4th A groups, the group number is its valence. That means first A group 1, and second A group 2, third A group 3, and fourth A group 4. But later on, means 5th to 5th A to 8th A groups, here we apply a formula that is nothing but 8 minus group number formula. Nothing but, for suppose it is a 6th group element, 8 minus 6, that is nothing but 2 for the 6th A group valency. And the same way 7th A group valence 8 minus 7 1, and 8th A group valence nothing but 8 minus 8 0, so that's why they are called as 0 group of elements. Okay, now next here the general electronic configuration of 8th A group also very important. That is nothing but NS2 NP6 configuration. This is stable configuration, noble gas configuration, very important. These elements are having this type of configuration. Okay children, so here in the periodic table lesson, here very important questions are explained here. Based on these concepts, you may prepare well for your examination. Thank you. Okay children, the next chapter is chemical bonding. Chemical bonding is nothing but the bonding between atoms, that is a attraction force of attraction between atoms to bind atoms together and to form the molecule. We know it. And chemical bonding is because of the redistribution of electrons. The redistribution of electrons may be of different ways, and different theories are there to explain the chemical bonding. Here mainly there are the different theories, namely valency electron theory. Valency electron theory are also called as electronic theory of valence, and mainly valence bond theory. VB theory also called as valency bond theory. And in between these two, there are also another concept of valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. These are the three different concepts covered in this chapter so far. Here the first valence electronic theory. This valence electron theory was proposed by the scientists Cosell and Lewis. Here Cosell and also Lewis. Here according to Cosell, here the ionic, he explains the formation of ionic bond. Here ionic bond explained by Cosell and Lewis explained the covalent bond. Here the ionic bond is mainly formed due to electron transfer of electrons. And the covalent bond is formed due to sharing of electrons. That is the key concept, sharing of electrons. So how a ionic bond is formed due to transfer of electrons and a covalent bond is formed due to a sharing of electrons. Both combinedly comes under valence electronic theory proposed by Lewis and Cosell. Here Lewis dot structures are very important to explain. Lewis dot symbols or dot structures. Here in this Lewis dot symbols or dot structures, only the element valence electrons only represented as dots or cross symbols. Like that, for example, lithium. Here concept 3 totally number of electrons and 1s2, 2s1 is the configuration and the valence electron is only 1. So lithium only 1. For suppose it is neon, that is a 10 electron number and 1s2, 2s2, 2p6 is the configuration of neon. Totally valence electrons are 8. So the neon is represented like this, 8 electrons. And for suppose it is fluorine with the electronic configuration with 9 electrons and 1s2, 2s2, 2p5. There are totally 7 valence electrons. Only we have to represent not 9, only 7 electrons with dot or cross symbols like this as a base 3, 2, 6 and 1, 7. So this is the Lewis dot structures which gives you 1 mark in examination. Okay. Next, here there are different ionic compounds. For example, here ionic compounds are NaCl, sodium chloride and magnesium chloride MgCl2, aluminum chloride AlCl3 and calcium chloride and also sodium monoxide Na2. So these are the different examples given in your textbook and which are important for your publication examination point of view also. And next, in covalent compounds, there are different covalent compounds are explained. Here hydrogen molecule and also Cl2 or F2 molecule or hydrogen chloride and O2 and N2 and different molecules like BCl2, BF3 and ammonia, NH3 and H2O, water and methane CH2. These are different molecules explained in our textbook. These are very important also in case of covalent bond. Okay. Now here there are difference also there in the valence electronic configuration, the valence electronic theory, and also which was later on that was modified by Vesper theory by different Sidgwick and Owen, different scientists. And actually here the mainly based to explain the angles and the shapes of the molecules. Next, here valence bond theory proposed by Linus Pauling. Here the concepts are mainly overlapping concept. Here overlapping of atomic orbitals and hybridization of orbitals. Hybridization. Okay. The same molecule formations are explained in different theories in different ways. The molecule system. Now we see the difference. Okay. Okay. For example, in case of valence electronic theory, the formation of hydrogen molecule is like this. According to Lewis concept, hydrogen, here one hydrogen and another hydrogen also there. Here they two electrons contributing their electrons and here they share the electron pair like this. Here we represent this type of notation. This is the one bond is formed with one pair. The covalent bond is indicated with a hyphen. So like this. H2 molecule, the film formation of H2 molecule. The same in case of valency bond theory, hydrogen is having their electron, single electron in 1s orbital, which is in spherical shape. Here this is the spherical shape 1s orbital, and here also another hydrogen also having 1s orbital in a spherical shape, having one electron. Here the electron is in opposite spin. These two orbitals overlapping each other, so giving rise to hydrogen molecule according to PV. Like this, here the two electrons share, so HH, hydrogen bond is formed. Here this type of overlapping is called as end-on overlapping, which giving rise to a sigma bond. Between hydrogen and hydrogen, there is sigma bond is formed due to SS overlapping. This type of overlapping is known as SS overlapping. This concept is based on the electronically balance. The same molecule explained based on the DB theory. And in the case, for suppose here this is a Cl2 molecule. How chlorine molecule is formed? Cl actually with the 7 electrons we indicate like this with the 7 valence electrons. Here also another chlorine also there with the 7 valence electrons. When these two chlorine atoms approaching each other, here they share the electrons here like this, and here the shape fulfills the octet configuration like this. The octet, this chlorine is satisfied, this chlorine is also fulfilled. So chlorine, between chlorine and chlorine, Cl2 is formed to explain based on this electronic theory of balance. And but in the same case here, the chlorine molecule is explained how in Levy theory. If you see, generally the chlorine having the single electron in 3pz orbital. The 3pz orbital nothing but here is in dumbbell shape. So here we represent the dumbbell shape 3pz orbital like this, and another 3pz orbital of another chlorine atom also having the opposite electrons. When these two chlorine atoms are approaching each other, their valence shell orbitals, nothing but 3pz orbitals, overlapping each other and giving rise to their PP overlapping like this. Here the overlapping is here, and they share the electron pair like this, and the shape of overlapping is known as PP overlapping, and also it is also another overlapping which giving rise to sigma bond formation between chlorine and chlorine Cl2 molecules. So in this way, I differentiate the two theories. And the examination, if he is asking, explain the formation of a chlorine molecule based on the electronic balance, you draw this diagram, and based on DBD, if you explain the chlorine molecule, you draw this diagram. So next, in the same sense, by adding these two H and Cl, HCl molecule is formed, and also here also you add the S orbital with the p orbital, you also gain the HCl molecule formation in DB theory. These are different types of questions. Okay, children. Now we go to the another main concept, that is nothing but the hybridization. Hybridization is different from overlapping. Here in case of overlapping, the two atoms orbitals overlap, but here within the same atom, here the redistribution and rearrangement of atomic orbitals giving rise of equal number of identical orbitals, the concept is known as hybridization. Here the hybridization is of different ways. There are sp hybridization and sp2 hybridization, sp3 hybridizations. See once here there are different examples such as BeCl2 molecule and boron trifluoride BF3 molecule, and next CH4, and next ammonia NH3, and water molecule. You can write this as OH2, but H2O molecule. And if you observe these beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8. Like this, here beryllium chloride, generally here in the beryllium chloride, the type of hybridization is sp hybridization, and BF3 molecule having sp2 hybridization, and CH4, NH3, and OH2, that is called water molecule. These are all in sp3 hybridization. Generally, here in beryllium the hybridization taking place. Here in sp hybridization, the bond angle is 180 degrees, and the shape is known as linear shape. And in the same way, BF3 molecule, the bond angle is 120 degrees, and the shape is known as trigonal planar shape. Trigonal planar shape. And now here CH4 molecule, bond angle is 109 degrees, 28 minutes, and ammonia molecule 107 degrees 48 minutes, and also OH2 water molecule having 104 degrees 31 minutes. And the shape of methane here, that is tetrahedral shape, tetrahedral, and next the ammonia shape is pyramidal shape. Okay, next water molecule is V shape or also known as angular shape. We are angular shape. So this table also helps to get core box examination. Also sometimes he is asking how many number of pairs in total lone pairs and bond pairs also. And in case of beryllium chloride, between beryllium and chlorine, here there are only 2 bond pairs, there are no lone pairs, and the total pairs are 2. And in case of BF3, there are 3 bond pairs, there are no lone pairs, the total pairs are 3. And next, in case of methane, there are totally 4 pairs, are bond pairs, there are no lone pairs, so the total pairs are 4. And in case of ammonia, there are 3 bond pairs and 1 lone pair, here the total pairs are 4. And here also in water molecules, 2 bond pairs and 2 lone pairs, and total pairs are 4. And here there is a difference in shapes because of the number of lone pairs and bond pairs. According to this concept, and this is the concept based on the Vesper theory. Okay, here the angle distortion in the angle is because of the repulsion between the bond pairs and lone pairs. So that's why we explain these. And you also practice different types of diagrams for 1 marks. That means BF3 or CH4, ammonia, and water molecules. Okay, children. Next, the very important questions from this lesson are: explain the formation of boron fluoride molecule and according to VB theory, or explain the formation of beryllium chloride molecule according to VB theory. Like that. And sometimes he is asking indirectly also, and explain the shape of pyramid shaped molecule. Okay, otherwise and sometimes he is asking about the electron deficient molecules also. Electron deficient molecule, nothing but the beryllium chloride and BF3 molecules are called electron deficient molecules. You see all the different types of combinations, and you prepare them. Okay students, now we are going to the next lesson, electric current. In public point of view, here this lesson is very important. Here, first of all, what is meant by electric current? Current is indicated with the letter I, and that is the net flow of charge through a conductor. Here, that is defined as like that, and this is a Q by T is the formula, and Q is nothing but the charge, and T is the time. And here Q is measured in coulombs, and time is measured in seconds. So coulomb per second, also called as ampere. Here the current is measured in amperes. That means the SI unit of current is ampere, and that is measured with the device meter. Okay, ammeter symbol is like this. Next very important concept is potential. Here that is potential difference, or simply called as potential. And potential is represented with the letter V. V is nothing but the work done by the charge. Here W for work done and Q for the charge. W measured in joules and Q is measured in coulombs, and here the joule per coulombs we call it as volt. And here volt is the SI unit of voltage, nothing but the potential difference or the potential, and this is measured with a device called voltmeter. Here in the circuit we see the voltmeter lines. Always keep in mind that always ammeter should be connected in series combination and voltmeter should be connected in parallel combination. Right. Next important concept is resistance. Here the resistance is nothing but the opposition for the flow of electrons or the flow of charge. Here the resistance is indicated like this zigzag symbol, and resistance is indicated letter R, and R is the ratio of voltage and the current. R is equal to V by I, which is another form of very famous law called as Ohm's law. Here here V is nothing but measured in volts, and I is measured in amperes. Here volt per ampere we call it as ohm. This is the symbol of the ohm. So ohm is equal to 1 volt per 1 ampere. For suppose if it is in kilo ohms, 1 kilo means 1000, so 1000 ohms known as 1 kilo. Here it is important to know what is Ohm's law, and very frequently is asked in examination how to experimentally verify the Ohm's law. Here at constant temperature, the current is directly proportional to the voltage across the conductor. So V is proportional to I, and simply we write this equation as V is equal to I into the constant R, that is nothing but the resistance. V is equal to IR is the magnetic representation of Ohm's law. Here, if you see the experimental result, and if you plot a graph between the voltage and current, here the graph is like this, that indicates the conductor which obeying Ohm's law called as a ohmic conductor, and for suppose like LEDs, gases and electrolytes, the graph is like this between the V and I. These are representing the non-ohmic conductors, also called as non-linear conductors. And he is asking examination, differentiate ohmic conductor and non-ohmic conductor. Also, you draw the graphs. Which obey Ohm's law, ohmic conductor, which do not obey Ohm's law, non-ohmic conductor. All the metals are ohmic conductors. Okay. Next, here the very important other concept in the resistivity. Resistivity is indicated with the letter rho. Okay. How resistivity comes? How it is different from the resistance? And here the resistance depends on some factors. Based on this, we derive the resistance. What are the factors based on influencing resistance? Here is one is the nature of the material. Next one is the temperature, and next one length of the conductor, and finally area of cross section. A. Represented here, this is L. And nature of the material. Every material has its own resistance. So, nature of the material influences resistance value. Okay, copper having different resistance, iron having different resistance, and tungsten and some other metals having different resistance. Temperature. Here, as there is also an activity, important activity, which come in examination. How do you prove the temperature affecting the resistance value? Okay, you read those experiments also. And here, as the temperature increases, we conclude that the resistance also increases independently. And length, here, as the length increases, resistance also increases. We represent the relation between the length and resistance is R proportional to L. That means as the length increases, resistance increases. As length increases, resistance also decreases. And based on that, we also generate one formula R1 by R2 is equal to L1 by L2, which is useful to solve some problems. Next, area of cross section. Here, area of cross section increases. That means the thickness, the area of cross section increases. Here, generally, the resistance value decreases. That means vice versa. Inversely, it relates. So, R inversely proportional to area of cross section, we write like this: R proportional to 1 by A. And we formulate like this: R1 by R2, which is equal to A2 by A1. Okay? This relation indicates the effect of cross-sectional area on the holes. That means, comparatively, a thin wire and thick wire, thin wire has more resistance than a thick wire. Okay, some problem. For suppose, if a 10 centimeter wire is there and the resistance is 8 ohms for suppose, and what will be the resistance of the wire if it reduces to half? That means the 10 centimeter wire is reduced to half. Generally, the centimeter wire having the 8 ohms resistance, and reduced to half means 5 centimeters. So that's why here that also reduced to half as 4 ohms by using this form. And if two wires are different, then only we can use this form. Otherwise, if I suppose if 5 centimeter wire is elongated to 10 centimeters, we can't use this type of formula. Why? Because here, as the length increases, the area of cross section decreases. So that's why we apply another formula. So the other formula is based on this resistivity. So resistivity rho is equal to R A by L. So that for any particular material, the specific resistance value is constant, that only affected by nature of the material and temperature, but not on length and area of cross section. That means independent of geometrical values. So this is the difference between the specific resistance and the resistance. Here the specific resistance is measured in the units of ohm meter. Ohm meter is the unit of specific resistance. Here we also use the formula R1 A1 by L1 is equal to R2 A2 by L2 for various problems. Okay children. Next, here there are some questions, and what is the why we use tungsten as a filament in electric bulb. Okay, we know that the chamber due to the tungsten's high melting point value and also higher specific resistance. And also in textbook there is a specific resistance table also there. Based on the table also they are giving some questions. And if it is a negative power, that indicates the here it is a very good conductor. That means low resistivity indicates the good conducting nature, like silver. And air, glass, rubber, these are all which is acting as insulators, which have the positive values of resistivity. That means higher resistivity and indicates the insulating nature. Okay, based on that you may answer the questions. Okay, the next important concept is series combination and parallel combination of resistors. Series combination of resistors and also parallel combination of resistors. In series combination, here the resistors are connected like this, and first of all this is the R1 and R2 resistors. And what is the effect resistance of these two resistors? Is nothing but the R effective is equal to R1 plus R2. Simple. The sum of the individual resistance gives you the effective or resultant resistance in series combination. Keep in mind that in series combination there is only one way for the current, and here the potential difference is divided but the current is same. In series combination, the same current and also potential difference is divided among the resistors like that. V is equal to V1 plus V2. So V is the total voltage offered by the battery. Here V1 is the voltage across R1 and V2 is the voltage across the R2. But the current is same. Along the resistance R1 also I current and along the resistance R2 also I current is V2. So this is very important concept. Next, in parallel combination. In parallel combination of resistors, we see like this. This is one resistor, this is another resistor. These two are like parallel lines. They are attached to another battery in series. And suppose this is R1 resistance and this is R2 resistance. And here the current having two paths, so current is divided here. Unlike the series, so current I is divided. But the voltage V is same across the components and resistors. Here also the voltage V, here also the voltage V. But the current here along the resistance R1 is said to be I1 maybe. Here this may be I2. Here I1 plus I2 gives you the total current in the circuit. Here based on this, the effective resistance or resultant resistance are in parallel, for example, is given as R1 into R2 by R1 plus R2. That is nothing but the product of the resistance by sum of the resistance. Here this is the resultant resistance in a parallel combination. And we also, the reciprocal of resultant resistance also equal to the reciprocals of sum of reciprocals of individual resistance 1 by R1 plus 1 by R2. This is another form. So if two resistors are given in the circuit in the problem, we use this formula. Otherwise, two or more resistances are given. Here we can use this formula 1 by R1 plus 1 by R2 plus 1 by R3 and so on. Okay. So based on this, I will explain now one problem. For suppose this is one type of question. For suppose here, see these are the 10 ohms resistors. Here each of 10 ohms, and here this is point A and this is point B. And what is the resultant resistance between point A and B? The way. Here you see here this is one way. So current has only one path. So these two are considered as in series, and these two also in series. The total here is 10 plus 10. The total in this loop, in this line, is 20 ohms resistance are there. Here also 10 plus 10, 20 ohms resistance are there in this loop. And this is 20 ohms and this is also 20 ohms. So this 20 and this 20 are appeared in parallel. So we have to apply the formula. 1 by R is equal to 1 by R1 20 plus 1 by R2 also 20. Like this, 20 is 1 plus 2. So 2 by 20. This is the reciprocal of resistance. So resistance equal to 20 by 2, nothing but 10 ohms. So between A and B, the result resistance may be of 10 ohms. Like that you may solve the problem. And for suppose if here we join like this in the examination, the circuit is joined like this, then this is different. And don't confuse, and you clearly answer the question. First, here these are the two ways, and this may be the common one. So distance and distance, first they are in parallel, and distance and distance also is parallel. The two are in series. So 10 and 10 parallel combination. So R is equal to 1 by R is equal to 1 by 10 plus 1 by 10. Nothing but here 10, 1 plus 1, that is equal to 2 by 10, that is equal to, so this is 1 by R value is nothing but 10 by 2, that is equal to 5 ohms. Here, the total here 5 ohms are there. In the same way, here also 5 ohms. So 5 plus 5 ohms totally in this, the resultant resistance, effect resistance is equal to 5 ohms plus 5 ohms, totally 10 ohms. So, if the circuit is changing, the answer is here 10 ohms, here also the answer is 10 ohms. Okay, like this we solve the problem. So, in this lesson is Kirchhoff's laws. Actually, Kirchhoff's, there are two laws. One is junction law and another one is loop law. Here, the junction law also called as current law. And here the loop law also called as voltage. Here the current law is a consequence of law of conservation of charge. Here this is the consequence of law of conservation of energy. Here in junction, at any junction, for suppose there are different circuits, different electrical wires are combined together, and here this may be a junction more than 3 or more than 2 electrical wires meet at a point. The point is in that junction. Here at this, maybe some currents are into the junction and some currents are away from the junction. Here, for suppose that this one is I1 current, I2 current, I3, I4, I5 like that. Here you see, here I1, I2 and also I5 are into the junction, and I3 and I4 are away from the junction based on this arrangement. So, according to junction law, at any junction, the algebraic sum of all currents is equal to 0. That means the sum of currents into the junction is equal to sum of currents away from the junction. Like this, I1 plus I2 and plus I5, which is equal to I3 plus I4. This is the representation of junction law. Okay, based on that, we solve the problem given by substituting the given values in the examination. And loop law. Here, loop law states that in a closed circuit loop, the algebraic sum of all voltages across various components in a closed circuit loop is constant. That means either increases or decreases, it will be constant. Here, by applying the loop law, we have to follow the sign conventions. Here, you consider one loop like this. For suppose this is the loop. For suppose here, for suppose here this is the 3 ohms and this is the 2 ohms and the current is 5 ampere current. And based on this, what is the, here this is the A, B, C, D is the loop, and what is the value of battery? That means how much voltage is offered by the battery. Here he may ask in examination by using the Kirchhoff's loop. Here consider this loop ABCD based on your wish. That means either in clockwise direction or in anti-clockwise direction based by choosing any point. Maybe you can choose A, B, C, D like this, or D, C, B like this, or C, B, A, D, or C, D, A, B like this. For suppose if I consider the ABCD loop, you must write that loop in loop A, B, C, D. What loop we will consider? You write the loop name. Next, if you go to A to B, first the component means not the RMR, keep in mind, only the component means either the resistor or the voltage. Only in case of loop law, only all the terms should be voltage terms only, but not individual current terms or not individual resistances should not be written in the expression. Okay, here the sign conditions are, for suppose in case of battery, in case of a cell, if you go from the positive terminal to the negative terminal, the voltage, that means plus to minus, if you go, that is taken as negative. The voltage is taken as negative. And otherwise, if you go negative terminal of the battery to the positive terminal of the battery, that is taken as positive plus. This is one of the dimensions in case of cells. And in case of resistors, you multiply the resistance value with the current value. How much current is passing through the resistance? Here, for suppose the 5 ampere current is passing through the resistance. So we multiply the R value with I value. Here the product I into R gives you the voltage. Simple. So here if you move in the direction of the current, the term is negative. And if you move in opposite direction, that is positive. The term is positive. So if you apply these sign combinations, here in case of ABCD, here we are going from positive terminal to negative terminal, the voltage is -V, and also I am moving in opposite direction of the current direction. Current direction is given this direction, this towards the left side. But I am going from A to B towards the X side, so that is opposite. And the total voltage here across the resistance is 3 into this 5 amperes. 3 5 15. So this 15, this is the volts, and I am going in opposite direction, so that is taken as positive. And also from B to C there is no component is there. So C to D there is one component resistor, and I am going from C to D. Again I am moving opposite direction of the current direction, so that's why again I am taking the positive value by multiplying the current and the current 5 ampere current with the resistance 5 into 10, so that is 10 volts is also. And the total D to A, the circuit is closed again, so equal to G. In this way, minus V is equal to minus 25. Totally V is equal to 25 volts. So the battery voltage is 25 volts. Like that, by using the loop law, one can answer the question. Okay. Next, here the next concept is electrical power. Electric power. Generally, power is nothing but the work done per unit time. So power is equal to by time. So work is measured in joules and time is measured in seconds. Joule per second is the unit of power, and generally power is measured in watts. So the SI unit of power is watt. The electrical power is also defined as the product of voltage and current. So in this way, volt into ampere also the unit of power. So the volt into ampere also known as watt. Okay. So power have different formulas. Power is equal to V square by R. Another formula. Power is equal to I square into R. This is another formula. So based on the data given in the problem, one can use different formulas. So you may practice those questions in examination. For examination. Okay. Next, very frequently in examination, he is asking about the current bill calculation. So for suppose a home is having fitted with 4 bulbs and 2 fans and 1 TV with different power consumption values. How much electrical power is consumed, electrical energy is consumed, like that is asking. So that the question is also very easy, and you have to calculate the total consumption of all the electric energy, and also you multiply that into 30 days. And to convert that into kilowatt hours, that is nothing but 1 unit. So you divide that into 1000. So 1 kilowatt hour, that is nothing but 3.6 into 10 power 6 watt seconds. So this is also important bit for examination. So the units calculation is like that. And very important thing is about overload. How the overload is prevented in your homes. So generally overload, to prevent overload, we can use a fuse. The fuse must be connected in series. Keep in mind. Okay. Okay children, the next topic is electromagnetism. The electromagnetism, if you observe the writing here, that is based on the 2 chapters, electricity and magnetism. That is a combination. Here, the relation between electricity and magnetism first identified by the scientist Einstein. So very famous with the Einstein experiment. You must read the Einstein activity. So what is the conclusion of the activity? Einstein activity. Here he proved that every current carrying conductor produces a magnetic field. That means if current is passing through a wire, so a magnetic field is produced around the conductor. That is a very famous experiment. You must read that first. Next one, here what is meant by magnetic field? Magnetic field. So the influence of the magnet up to which region that is affected, that region is around the magnet is called as magnetic field. And what is present in the magnetic field? Nothing but the magnetic lines of force. Magnetic lines of force. Magnetic field lines. Also called as magnetic field lines or magnetic lines of force. And they are crowded at some parts and they are uneven at some parts. And based on that, the magnetic strength is also different. The number of magnetic lines in an area called as magnetic flux. Magnetic flux, which is indicated in letter phi and which is measured in terms of webers. That is number of lines simple. And here the magnetic flux passing normally through an area, that is called as magnetic flux per unit area, that is indicated with the letter B, which is nothing but the magnetic induction, are also called as magnetic flux density. And phi is measured in webers, A is measured in, area is measured in meter square. So Weber per meter square is the unit of the magnetic induction B. So this Weber per meter square we call it as Tesla. So the SI unit of magnetic induction is Tesla. Okay, there is also different cases here based on this phi is equal to BA. Actually, represented with the BA cos theta. Here theta is the angle between the normal drawn to the plane in the field and also to the field lines. Here, right? Here there are different cases also. You also practice those cases. In a perpendicular case, that means when the plane is perpendicular to the field, and in that case maximum flux is there. In that maximum flux, the phi is equal to BA, and this is the maximum case. And the plane is placed parallel to the field, and in that case here only there is no flux, so the phi is equal to 0. So these are the different cases. Next concept is here what is the force? Different types of fields formed by different situations. So one of such situation is the magnetic field due to a straight wire carrying current. There is very important experiment in this chapter. So in this also we proved that here there is a table. On the table there is a wire also. So through the wire we pass the current, and also by placing the some of the iron filings or by using some magnetic compasses. Here some field is produced around the current carrying wire in that. And to observe the direction of the magnetic field lines, we use right hand rule. Also simply right hand thumb rule. Right hand thumb rule. Here imagine that suppose there is a current carrying wire in your right hand such that along the wire, along the thumb direction the current is passing, and the thumb indicating the direction of the current in the wire, and here the remaining curved fingers indicating the direction of current, direction of magnetic field around the wire. For suppose here this is the direction of current and the magnetic field is like this here, and how the fingers are curling around the wire, that is the magnetic field. Here to represent that, for suppose here this is the wire is into the bone, we represent that with the into symbol, and the circular field lines are formed. That means the field around a wire, field lines are circular in nature. That means magnetic field lines are closed loops. And what is the direction of the field lines? Here you see the thumb is into the bone. So into, that indicates the current is into the bone, into the base. And the remaining curved finger direction is like this, that is nothing but the clockwise direction. So the current is into the base, the field is clockwise. And for suppose, see like this, the thumb is out of the base, that means away from the board perpendicularly. So we indicate with a dot symbol, and the field lines are circular concentric the curl fingers direction, the curl fingers are in anti-clockwise direction. This is anti-clockwise, and that means here if the current is into the phase, the field lines are clockwise, and the current is out of phase and the field lines are anti-clockwise. Based on this also some examination questions are coming. Okay, next here the magnetic field due to a circular coil also there, and the magnetic field due to solenoid, that is very important. A solenoid is a closed back helix, that is like a spring. Here you see this acts like a bar magnet, similar to the bar magnet. How the bar magnet having north and south poles, and here if you compare this with the bar magnet, north and south, and the direction of magnetic field is from north to south. We know that outside the bar magnet. In the same way here also, the two ends of the solenoid acting, one has north pole and the other one is a south pole. And in the in which the current is in anti-clockwise direction, that end is acting as a north pole, and which the current is in clockwise direction, that is acting as a south pole. And here by passing the current, the solenoid itself behaves like a bar magnet and forms some of the field lines also like this. And this is an activity to prove the magnetic field lines are closed. Either the question if he is asking how do you prove the magnetic field lines are closed loops, you can write this activity or otherwise the table activity like that, which is by using the straight wave and compasses. Okay, field lines are closed. And simply here, if you observe outside the bar magnet, the lines are from north to south, but inside that the field lines direction is from south to north. That means in solenoid the field lines are coming from south to north and outside north to south as like the bar. So this is one of the important question. The next concept is force acting on a moving charge or on some current. So when the charge is moving, that is placed in the external magnetic field, or a current carrying wire is placed in the external magnetic field, in that case some force is acting on that wire or charge. How much force is acting, in which direction the force is acting is. Here for suppose we can calculate the force with the formula F is equal to Q sin theta. That means here theta is the angle between the charge velocity and also the field, direction of the field and the velocity, and theta, and V is the magnetic field induction, V is the velocity, and Q is the amount of charge which is measured in joules. By using this formula one can calculate how much force is acting on the particular charge when it is moving in a